Welcome to 3.2 Differentiability, where we will continue in part 2 and focus on a concept called local linearity. Again, linearity is just a fancy math word to describe linear, something that makes a line, a function that makes a line, and local just means like zooming in. Take a look on this graph here. I've hidden what the function is. It looks linear, doesn't it? It looks like a line. We're pretty far zoomed in. You can clearly see at the bottom of my Desmos graph screen down there, they're going by tenths, and same with the y-axis. So we're pretty far zoomed in. So it looks like a line here, and it almost is. What I'm going to do is zoom out slowly and show you. Whoa, it zoomed in even more. That's cool. Just more proving my point. Let's zoom back out and take a look at what this function actually is. Whoa, it looks quadratic. And then we zoom out even more and we see that it's actually a cubic function. This is the function, I just put in a random function, x cubed plus 6x squared. And how cool is that? That's what local linearity means. It means when you zoom super far in and focus on some singular point on a function, that it basically starts to look linear. It looks like its own tangent line at that point. And if a function is differentiable at that point, you can zoom super far in on that actual point and it basically looks like a tangent line, meaning, hey, it's differentiable at whatever point I zoomed in on. That means I can draw a tangent line there. It starts to actually look like its own tangent line. So local linearity is, it's the idea that a function is differentiable at that x value and it closely resembles its own tangent line if you zoom in far enough. So if you go locally enough into the graph, it's basically linear. So differentiable curves, or any polynomial, will basically straighten out if you zoom far enough in on them at any point. This polynomial, because it's a polynomial, is differentiable at any point in its domain, which is all reals. And whatever x value we zoom in on, no matter the x value, it will look linear. And that just means it's differentiable at that x value. So that's the idea of local linearity. Differentiability at a point implies local linearity at that point, and a polynomial is differentiable everywhere. Therefore, whatever point we zoom in on, it will be locally linear. Why is the absolute value function the probably most famous function for having a corner? Why is this not differentiable when at its corner? In this case, at x equals 0. Well, differentiability implies local linearity. So if we're differentiable at a point, that means we're locally linear. So let's zoom in at the point where we know we're not differentiable, when x is 0 in this case, because there's a corner there. And so far you only know that we're not differentiable because there's a corner. But we want to kind of talk about the calculus behind that, the idea behind that. If we are to zoom in at that corner, no matter how far we zoom in, note at how tiny these intervals are getting. This is so cool. I could do this forever. No matter how tiny those intervals are getting, we never form a line. This is kind of trippy. We never get a line. It's always a corner. And so if you look at the derivative from the left of 0 and the derivative from the right of 0, the derivative as we approach 0 from the left is -1. This is just the line negative x. It has a slope of -1. Its derivative is -1 here. And from the right, our derivative is +1. So at x equals 0, or wherever our corner happens to be on whatever absolute value or other function with a corner that we're looking at, no matter how far we zoom in, the derivatives never match up from left to right and therefore never make a line. It's not locally linear at that point. And a line means that we have a constant derivative or constant slope. It's always changing and we're always going to have that corner no matter how far we zoom in. So because we're not locally linear, our derivative is never the same all the way through. It never forms a line. Therefore, we're not differentiable at a corner. And that's kind of cool. We are differentiable at every other point because this literally is a line anywhere else and it would be its own tangent line. So this function here is only not differentiable at its corner, which is x equals 0. The same idea works with a cusp as you could imagine, a cusp would just be kind of like curvy, I guess, in this case, like that. It would have the same exact idea. It would not be locally linear. My last little spiel about this is whenever I talk about local linearity, the few times that I have taught calculus, I always think about the phrase think globally and act locally. And I remember a teacher introduced this phrase to me when I took AP Calc my senior year of high school back in 2008. And it really stayed with me. And especially, I'm a millennial, but your generation, I feel like, I see all this stuff on TikTok and I see how active your generation is politically, and I think that that's really cool. It gives me a lot of hope for the future. But it is interesting in a mathematical way. In our first example, when we had just that line, and it looked like a line, but then we zoomed out and we saw that it was so much more. And that just has always reminded me of this. However you act locally and whatever you can do to improve the world, if everybody does that, then it works out globally. So it's kind of like doing your own little thing. It may seem small, but it really can help the world. And I'm just feeling some type of way today, so I just wanted to include this adorable picture of my daughter, Elena, and that was taken yesterday morning. She's 7.5 months old. And I do always appreciate the little things that young people do that better our world, and I always think about her. So local linearity kind of has a special spot in my heart, not only because it's a really cool concept mathematically, but it's kind of like you zoom in and you're doing something, and then you zoom back out and you see just this broader picture of things. And I just really like that idea. So I hope you guys do too.